All right, so now we're getting into section 7.5, and this is talking about trigonometric relationships. Now we've got relationships that we know. We've got the inverse relation, or sorry, the reciprocal relationships that secant is 1 over cosine, cosecant's 1 over sine, cotangent's 1 over tangent, and all that stuff. We've also got that tangent is sine over cosine, and that cotangent is cosine over sine. We've got those relationships we can work with, and we're going to add a couple more. All right, relationships between the 6 trig functions are called identities because they are true for any value of theta. In other words, whatever value you plug in on one side of that identity, you can do the exact same thing everywhere else in it, and it's still going to be equals. Now, equivalent form of trig functions can reveal relationships, simplify complex expressions, help solve equations, and can be used to generate even more identities. So, the main one that we need to look at today is the Pythagorean identity. And it is based off of the Pythagorean theorem. And that hopefully would make sense since it's called Pythagoras. But what we're dealing with here is we've got a unit circle, radius of 1, and we know the x value is going to be cosine theta, whatever this theta is, and this side is going to be sine theta because the x and the y because of the x and the y. So when we do Pythagorean's theorem, remember it had to be a right triangle, which this is, and the 2 legs that were not hypotenuses, that were not the hypotenuse, you would just square those, add them together, and they're going to equal whatever the hypotenuse is squared. So in this case, you could think A is cosine, and B is sine, and C is 1. A squared plus B squared equals C squared. Sine squared plus cosine squared equals 1 squared. Now, from those, we can get all these others. Now, these are really easy. Guys, I'm going to be honest with you. The only one that I remember is this one. That's the only one I commit to memory, and it's not really hard to remember because of this relationship. These we can derive directly from that. So we've got 1 plus tangent squared theta, and guys, notice that all these are squared. None of them are single. So it's not 1 plus tangent equals secant. That is not an identity. There are instances where that's true, but they're few and far between. All right, so 1 plus tangent squared equals secant squared. So let me show you how you actually get that. We're going to start off with this thing. So sine squared theta plus cosine squared theta equals 1. And what we're going to do is we're going to divide both sides by cosine squared. So I'm going to divide that side by cosine, and I'm going to divide this side by cosine squared theta. Now, if you don't know your algebra, this is not going to work for you to be able to figure this thing out. If you do, you're fine. Now, cosine squared theta that's on the bottom, remember it has to be divided into all parts on the top, not just the one that it cancels out with. If you come out with sine squared theta plus 1, you've done it wrong. It's sine squared theta divided by cosine squared theta, which gives me tangent squared theta, and cosine squared theta divided by cosine squared theta, which gives me plus 1. And then over here, 1 over cosine squared theta, which gives me secant squared theta. Now, guys, the thing is, sine squared theta is nothing more than sine theta squared. So when we're doing this, we literally have sine theta times sine theta divided by cosine theta, So that's going to make a tangent, and that's going to make a tangent, and we multiply them together, and that's where the tangent squared comes from. Don't overcomplicate it. So we can do exactly the same thing with this one, and let's shorten things up just a little bit here. We'll start off with the sine squared theta plus cosine squared theta equals 1. And now we're going to divide by sine squared theta. So we've got sine squared theta divided by sine theta. Sine squared theta gives us 1. Cosine squared theta divided by sine squared theta gives me cotangent squared theta. And then 1 divided by sine squared theta gives me cosecant squared theta. So I can derive these two by just remembering this thing. And just remember, the sine squared theta is just sine. You can rewrite it like this if you need to, if it makes more sense. It's just sine theta, the value of that thing, squared. You're taking the sine first, then you're squaring it. Because you cannot square just the sine. It has to be the value that you get from sine theta. Then you can square that. All right, so if secant theta equals 4, find cosine theta, tangent theta, sine theta, cosecant theta, and cotangent theta. Now, here's the little trick with this. If you can find cosine and sine, you found everything else, because if you think back to your identities of what those things are, everything's based off of cosine and sine. So if we know that secant theta equals 4, that means that that's equal to 1 over cosine theta, and then we can flip this over and we get cosine theta is equal to 1/4. You could also multiply by cosine theta and then divide by 4 and get the same thing. But we know that cosine theta equals 1/4. Now, once we've got cosine, we can find sine really easy by the Pythagorean identity. Remember, if we know that sine squared theta plus cosine squared theta equals 1, then what is sine theta going to be? Well, we can solve this and say sine squared theta is equal to 1 minus cosine squared theta. And then we can say that sine theta, we take the square root of both sides, is equal to the square root, plus or minus, of 1 minus sine. Nope, wrong. Sorry. This one doesn't change. Cosine squared theta. Now, guys, when you take the square root of this, please don't take the square root of 1 and the square root of cosine squared. You have to put this together and get that value before you can take the square root. Don't take the square root of the 1 and the square root of the cosine squared. That does not work. That does not work. All right, so sine theta is going to be what? Well, all we're going to do is we're going to plug in. So sine theta is equal to plus or minus the square root of 1 minus, and cosine theta we've already found to be 1/4, so when we square that, we're going to get 1/16. So that means I've got plus or minus the square root of 15 over 16, which is equal to plus or minus the square root of 15 over 4. Because I remember, to take the square root of a fraction, you take the square root of the top and the square root of the bottom. I can take the square root of the bottom, I can't take the square root of the top. Now, we put the plus or minus in there, and remember, it could literally be a positive or a negative depending on what quadrant we're in. But the thing is, this value right here only gave us the cosine value. It tells us that it's going to be in quadrants 1 or 4, because cosine is positive right here. It doesn't tell us whether it's in quadrant 1 or quadrant 4. So if it doesn't tell you, go ahead and take the easy way out and put it in quadrant 1. So that would make this a positive 15 over 4. So now once we have sine and we have cosine, we can go and we can find everything else. So now tangent theta is going to equal what? It's going to equal sine theta over cosine theta. So then when we write that out, we're going to have square root of 15 over 4 divided by 1/4. Keep, change, flip. Square root of 15 over 4 times 4 over 1. The 4's are going to cancel, so we end up with the square root of 15. All right, now what do we know about the cotangent? Well, remember, the cotangent is just that thing flipped over. So it's literally 1 over the square root of 15. Now, you do not have to rationalize, but if you want to, you would end up multiplying by the square root of 15 over the square root of 15, and you end up getting, let me move this up a little bit, 1/4. You end up getting the square root of 15 over 15. All right, so we've got the cosine, we got the tangent, we got the sine, we got the cotangent. The only thing we've got left is cosecant. Remember, cosecant theta is nothing more than 1 over sine theta, or just the reciprocal of sine theta, and that's going to end up with 4 over the square root of 15, which if you rationalize, you're going to get 4 square roots of 15 over 15. So there's all our values. All right, for questions 2 through 4, simplify each trig expression to one number or trig expression. All right, so the first one here, we got secant squared theta. I can do some things with that, but I'm not looking at doing anything with it right now. And here's why. It's a single. If it's a single term, I want to leave it by itself unless I absolutely have to change it. This one is a double. It's got more than one part to it. So is there any way that I can rewrite this thing as one term? Well, if you remember, sine squared theta plus cosine squared theta, and you need to know these guys. You need to know them and know them in their other forms too, what's going to happen when you algebrate them. So here we would subtract the sine squared theta minus sine squared theta. So it's going to cancel out there and leaves you with cosine squared theta is equal to 1 minus sine squared theta. So that means that in place of this, I can write cosine squared theta. So I've got secant squared theta times cosine squared theta. And what do I know about secant squared theta? Well, secant squared theta is just 1 over cosine squared theta times cosine squared theta, and that is going to cancel out to leave me 1. All right, so number 3, cosine squared x plus sine squared x, guess what? That's still going to be 1. They're both positive in the expression. You can add them in whatever order you want to. So this is going to be 1 over secant x, which is going to be what? Cosine x. All right, and number 4, secant squared x minus tangent squared x. Well, that makes my spidey sense go off just a little bit. So what exactly am I looking at? Well, I'm looking at probably one of those trig identity, the Pythagorean identities, rewritten. So I need secant and tangent. So remember, if you don't remember it off the top of your head, derive it. And if I want secant, that's going to be dividing by cosine. Dividing by cosine. but I don't want to do that. But if I want to get tangent, I'm going to have to divide by, yeah, I'll divide by cosine. Cosine squared theta, cosine squared theta. And then we've got sine squared over cosine squared gives us tangent squared. Plus cosine squared divided by cosine into cosine squared gives us 1. And over here we got secant squared theta. So then what I can do, and I can subtract tangent from both sides, tangent squared theta minus tangent squared theta. And those are going to cancel out, leaving me 1 equals secant squared theta minus tangent squared theta. And it's just a little stretch, little skip for you to change the x's to the thetas or the thetas to the x. Remember, they're just representing a value we're going to plug in later. As long as the values are all the same, you're going to be perfectly okay. Just keep them all the same. As long as they are all the same to begin with, you can change all of them over to x's. If one's a theta and one's an x in the original problem, then you can't just change them all to 1. They separate and mean different things. It would be like if you had secant squared x minus tangent squared y. You can't just magically make both of those x or y. All right, so we know that secant squared x minus tangent squared x, which is what I've got right here, is equal to 1. Now, guys, if you have one of these as a free response question, you've got to show this work. So you could get in here and, well, what's a good way to do that? Oh, well, you could just go ahead and move your tangent squared to the other side and get secant squared x equals 1 plus tangent squared x. Start off with your identity and then just show that you move that to the other side, that it equals 1. As long as you start off with the identity, then you can do anything you want to rearrange it. But you got to start off with an identity, with an understood identity. Don't start off with something else. So once we got to right here, we could write that, nope, actually, yeah, right there. We could write that in here, and then we could rearrange this to get secant squared x minus tangent squared x equals 1, and then there's your answer. But you have to start off with something that is known and understood to be an identity and go from there. All right, so number 5, we are solving sine squared w plus cosine squared w plus cosine w equals 1/2 for all values of w on the interval from 0 to 2 pi. All right, so first thing we need to remember, when we're solving for one of these trig functions, we need to isolate that thing if possible. Well, looking at this, there's no way you can solve for just cosine or just sine. So you need to look for identities in there that are going to simplify this expression. Well, hopefully it jumps out at you and has been jumping out at you ever since I said this. Sine squared w plus cosine squared w is just a big fat 1. Remember, if they're equal, they're interchangeable in any algebraic expression. So it doesn't matter that I've got this right here, because I know sine squared of an angle, whatever angle it might be, whatever we're calling it, plus the cosine squared of that exact same angle is always going to be 1. It's an identity. We can interchange that anytime. We don't even have to be necessarily talking about trig functions, but magically if that pops up, it's equal to 1. And we can simplify and get less trig functions there. So now we want to find out what w is, so we need to identify and isolate cosine w. So we're going to subtract 1, so we get cosine w is equal to negative 1/2. So now we're going to take the arc cosine of cosine w and the arc cosine of negative 1/2, and we're going to find out what W is. Now, remember, what do we know about cosine? Cosine is 1/2 at the pi over 3's. It's going to be negative. We're going with cosine, we're going from 0 to 2 pi, from 0 to pi. So if we're looking for where cosine is negative 1/2, we're looking over here. We're looking in quadrant 2. So that's going to be 2 pi over 3. And is there anywhere else that it's going to be negative 1/2? Remember, the arc cosine is only going to give us the 1 because it's going to give us the value between 0 and pi. But if we're looking for all of them over the interval from 0 to 2 pi, there's another place in here. Remember, it's where your what? Your x value is 1/2, so it's going to be down in quadrant 3. So what's my pi over 3 angle that's down in quadrant 3? Well, that's going to be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. All right, so which one of the following is not equivalent to cotangent of beta? And that's the Greek letter beta. And just so you know, in case you run into it, beta it's just like theta. It's just we typically use Greek letters to signify unknown angles. You'll also see, that's not right. That, which is alpha, and then beta, lowercase alpha, lowercase beta. Yes, that actually is a lowercase. So now, which one of these is not going to simplify to cotangent b? So cosecant squared b minus 1. Well, remember our cotangent, we've got, if we start off with sine squared theta, and we'll just go ahead and do beta, plus cosine squared beta equals 1. If we want cosecant, we're dividing by sine. So we got sine squared beta, 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 divided. All right, and guys, this is not the work. I'm showing you. I always derive that just to make sure that I got it right. I don't memorize it. I have a finite amount of memory left in my brain, so things like this are really easy to do. So it may take me 30 seconds if I'm doing it by hand, not explaining as I go through it. But I don't remember the other two trig identities, the other two Pythagorean identities. I just remember this one. All right, so if I divide, I'm going to have 1 plus cotangent squared beta is equal to cosecant squared beta. All right, so if I move that over to the other side, I now have cotangent squared beta is equal to cosecant squared beta minus 1. So now if I take the square root here and the square root there, then the cotangent squared beta, just cotangent beta is going to equal the square root of cosecant squared beta minus 1. So ding, 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 that one checks. That one is equivalent, so it's okay. Cosine beta over sine beta, well, that by definition is the definition of cotangent beta, so that one checks. Secant squared beta over, or secant beta over cosecant beta. Well, here's a little trick with that. Remember, this is 1 over cosine beta. That's the definition of secant. And this is 1 over sine beta. And then keep, change, flip. So we've got 1 over cosine beta times the reciprocal of that, which is going to be sine beta over 1. Multiply across the top, multiply across the bottom. We got sine beta over cosine beta. and that is going to be tangent beta. So that one's not going to be equivalent to cotangent beta. Now, just to make sure, go ahead and work with this last one here. Cosecant secant, that is 1 over sine beta times 1 over cosine beta minus tangent beta. All right, so I'm going to move down here below this, so I've got some more room there. So we can get, remember we're multiplying there and we're subtracting here. That's not a long t cross on the t, that's subtraction. So we can get 1 over, we can combine this together to get 1 over sine beta cosine beta minus, and tangent is just going to be sine beta over cosine beta. And we're going to need a common denominator to be able to put these together into one fraction, because we're trying to get it to equal one thing. So we need to make it look like one thing and see if it'll simplify down. So that means we're going to need to multiply by sine beta over sine beta. Now, the reason why I'm doing that is because if I multiply this thing by sine beta over sine beta, that is just 1. It's not changing its values, just changing what it looks like. And if I multiply cosine beta times sine beta, I'm going to have the same thing on the denominator that I have over here. So what we end up getting is we end up getting 1 over sine beta cosine beta minus sine squared beta over, and I'm going to rearrange these and put them in the same order so they look alike, sine beta cosine beta. So now, common denominator, we can actually put these two together. So we end up with 1 minus sine squared beta over sine beta cosine beta. And you're probably thinking, well, what the crap, that didn't help much. Hey, remember what that is. Remember what this thing right here is. We did it in the last example. That is nothing more than cosine squared theta. So now, replacing the top with cosine squared theta over sine, not theta, beta, sine beta, cosine beta, and this cosine beta right here will cancel out with one of the ones we've got up there. So that means what we end up with is cosine beta over sine beta, which is going to be cotangent beta. So that one works out as well. So the only one that did not work out would be C. So that's the answer we're looking for because it's not equivalent. All right, hope that helped a little bit.